First off, I just want to say thanks so much for joining us. We're always excited to have all this participation from our membership. And I think this is going to be a great session. If you're not familiar with CANBIM and you're just tuning in for the first time, CANBIM is a national organization focused on technology and innovation. We have about 800 members spread across the entire country of Canada. And everyone who participates in this organization is very focused on improving the industry through innovation and technology. And we have a number of different programs where you can participate, build your network, learn from other people, share information. So go and check out our website for that. And I just want to highlight that we have a think tank that's been established around this subject matter, today's subject matter. So go check that out. I believe that we're actively recruiting from our membership for people that want to participate there. So this session is going to be hosted by Cesar Ruest and Patrick Mays. They're both from Dassault Systems. They both specialize and focus on the AEC market, and they both have deep expertise and many years of experience around helping companies use digital technologies. So Cesar he's got about 20 years of experience. He's really been focused since I've known him for probably 10 years on working with executives and helping them with technology strategy. And Patrick Mays, who I've just met recently, has a really extremely impressive pedigree. He's based out of the U.S. and North Carolina, I think South Carolina. Maybe you correct me on that, Patrick. But he has an international focus. I believe he spends a lot of time in Europe working with customers that want to start up their offsite initiatives. So I'm going to invite them to come in to the session here, and thank you so much, guys, for putting on this session, and I'm excited to hear what you talk about.
Well, let's get started. So we're going to be talking today about design for manufacturing and assembly in the construction industry. What's happened in other industries is a little different, and construction is a special case. I've been working now with Dassault for about 12 years, but I have about 40 years of experience in the industry, 25 or 30 of that as a practicing architect. So I have lots of hands-on experience to bring to this. The agenda today, I'm breaking into these three parts, talking about the new business context that we're working in, what I'm calling new economies. I'd like to talk about some of the legacy challenges we have with BIM in the industry, and then focus on how DfMA can address those changes that are coming about. I'll take a pause at the end of each part and see if there have been questions that have been posted in the chat space. And Cesar will take a look at a few of those and see if we need to clarify anything as we go. When I talk about new economies, I'm talking about things like the sharing economy. But I think it's not just what's happened in the past 5 or 10 years. Really, it goes back 20, 30 years. So I like to start by talking about the elevator industry, or as they call it in the UK, the lift industry. This is an article from The Economist from about 7 years ago. And my personal experience here was working in San Francisco in the early 90s with Trammell Crow as the developer of high-rise buildings in San Francisco. They were working on 4 or 5 at that time, and I was the architect for one of them. PCL was the contractor for the project. And as the architect, Trammell Crow said, just put a bubble in your drawings and say elevators provided by others, and PCL, we'll just take care of that, provide the shafts to us, and we'll take it from there. The reason that Trammell Crow wanted to do that is they would get a 20 to 25% savings on the cost of the elevator by having the contract go directly to the manufacturer. And from the manufacturer's point of view, I think this Economist article makes it very clear. There's just 4 firms that have about 2/3 of the global market, and Otis is one of the biggest players. And many times Otis is actually managing and operating elevators manufactured by others. But the margins for these elevators are 20 to 35% for the maintenance and operation phase. And during the manufacturing and installation phase, they're only making about an 8 to 10% profit margin. What that tells us is these companies want to be in the elevator operations business, but it's a necessary evil that they manufacture and install them in order to get that operations business. Their focus is really on the operations life cycle and the services that come along with it. Now, in terms of sort of Wall Street investment, they care about the ability for services to increase revenue in a very steady fashion. The construction market is very cyclical. From year to year, it might go up and down, or from decade to decade, it might go up and down. But if you've got a large installed base of elevators, as an example, you've got steady maintenance revenue to stabilize your income, and you're able to think of new services that impact all of those customers. So this model's been around a long time, and I think even though the sharing economy is speeding things up, elevators are a good example of how I think businesses can be changing in the construction market. So let's go to the sharing economy for a minute and make sure we're on the same page about that, what that means. Let's start with car sharing. I think that's familiar. So we have Uber and Lyft as ride-sharing services. We have Zipcar and FlexCar that are car-sharing services in a little bit different model. Near your home, there's a garage. There's multiple vehicles available to you. If you need a truck, you take that out. If you need a van, you select that. If you need a family sedan, you take that. You take what vehicle you need when you need it. Get-around's the opposite of that. It's almost like the Airbnb of cars, where if you have extra vehicles, you can park them in a garage someplace, and Get-around manages the sharing of the vehicles that you'd like to make available. So in this part of the economy, I think it's very clear the impact of sharing. And I think even in vacation rentals, whether it's the vacation rentals by owner or Airbnb, these kinds of services are pretty well understood by most of us these days. But Airbnb about a year ago decided that they would start designing their own houses that would be accessory dwelling units and backyards for people. And that would give them more brand control and a consistent quality experience. So now we've got the sharing economy companies beginning to think about buildings as products that are modularly delivered. Another aspect of the sharing economy and co-living is with Ollie in Boston and New York, and the Collective in London. These services are targeted to millennials or young people graduating from school. They may not be married and have children yet, and they're thinking of, as they're graduating, about a few of their friends who are graduating from the same school, and they all want to go to the same city together. Maybe they can share a flat in that city. But instead of one person renting the whole flat and adding on signatures, what you're actually renting is just a bedroom and a bathroom. And then with the other 3 or 4 people that are sharing the flat with you, you decide what other space and what other services do you want. Do you want a full kitchen and do your own cooking? Or do you want to have grocery delivery? Or do you want to have prepared meals delivered, in which case you just need a small kitchenette and not a full kitchen? Or perhaps you want to use the dining room that's in the building and you don't need a kitchen at all. Likewise, you could have a full laundry in your unit, or you could use the laundry service with the building. You could use the maid service with the building. There's lots of services that are provided in conjunction with the facility, and you decide what the right mix is for you. Collective in Europe is a little different than Ollie in the US. The Collective, you're actually getting a share of units in several geographies. So if you need to spend a month in Paris or a month in Amsterdam and you're back in London for 3 months, your preferences go with you. If you want somebody to do your laundry a certain way and do your dry cleaning, if you want meals delivered and you're a vegetarian or have certain preferences, all of that information goes with you. The type of vehicle you want to drive, whether you want your own parking space or you want to share a vehicle, all of the information goes with you. So this is a very different way of thinking about using space. And I think it's also probably more environmentally responsible. If we think about car sharing as an example, if everybody were to share cars, we would have 60 to 70% fewer cars on the road. And I think likewise, if we would share spaces, we would find that there was a lot more efficiency in the way we use building space, whether that's for living or for working. I think we're all familiar with WeWork as we move to this last category. Even though they've gotten into trouble financially, I think that this model of sharing workspace is here to stay. We also see companies like Google and Amazon moving into the living spaces and working spaces. They're focused on IoT devices. So whether it's a doorbell or a camera or a thermostat or any other type of device, they're interested in the data that they can collect in the physical world and how that compares to data they're collecting in the online world. And one way to think about this new economy is that the data collected is often more valuable than the device itself. Amazon, for example, probably charges about $10 for one of their Echo devices and a plug that might control it. But I think they'd be willing to give you those practically for free because the data that they're collecting has such high value. Likewise, the services provided by Ollie or Collective are so valuable that they become almost more valuable than the asset that they're renting. Now let's go from these better understood case studies to what it might mean in construction. And I like to start with appliances as a component of a building and move towards thinking of more and more of the building as if it were an appliance. This Samsung refrigerator, for example, it has a touchscreen on the outside. You can organize your menus across the week, and you can put in your favorite recipes. There's a camera inside. Some of these have barcode readers or RFID readers, those kinds of things. So it's aware of the contents of the refrigerator, and it sort of warns you when you're running low on something that you're not going to be able to complete a menu item that's on your weekly menu. And it's synchronized to your phone. So if you're at the store and you are wondering if you have enough milk, you turn your phone on, it turns on a camera in your refrigerator, and you can actually see the milk cartons and see if they're full or not. Likewise, you might be thinking about something in the store that you want to buy. Well, the app will also tell you exactly which shelf to go to and which items to pick up in the store. So it plans your shopping for you. It coordinates what you've got at home, and it does it through the intelligence in the store, like an Amazon Go store, the portable device like a cell phone or a tablet, and an appliance in your home. Now, these stores like Amazon Go are creating in the real world, a shopping experience that's like the online shopping experience. When my family went to the Amazon Go store in Seattle, they were recognized as they walked in because they had an Amazon Prime account and the phone acknowledged connection to the store. And importantly, as they select things from the shelf, these cameras are kind of keeping track of what you're buying. And if you take something from the shelf, look at it, and put it back, that data is also captured, just as if you were getting ready to buy something on the Amazon website and decided not to buy it. That kind of data is very valuable to these retailers. When you get ready to walk out of the store, it will ping you and let you know that this is how much has just been charged to your Amazon account. Now, here's a different example for you. This is a Miele washing machine that's a popular product in Europe and possibly in Canada as well. This particular model, I think, has something sort of like steam cleaning. It has regular washing and drying built into one unit. And the data is collected about the life of the machine in the machine itself and helps the company manufacture and improve products over time. But it also is connected to a smart device like a phone. So perhaps you're commuting home from work, you tell your machine to start up the wash cycle. So you know that it's actually finished washing, done mostly drying, and you can now hang out your sheets to get some fresh air if that's what you'd like to do. But what the machine is doing and your preferences are being captured, and that data has high value. So let's move from appliances now to think instead about how a building might be thought of in that same terms. So a bathroom pod, as an example, could be thought of as an appliance. You could plug it into a building and you could unplug it when you want to refurbish it at some point in the future. But imagine someone who wants to stay in the same building for their entire life and what they might want over time. Maybe when you're young and you're single, you want a small shower and a pretty small bathroom, but you get married and you want a little bit more space and you want maybe a two sinks in the bathroom, or you want some privacy in the toilet area or something like that. Well, you unplug the old product and you plug in the new product. And then maybe you have a baby and you decide the shower doesn't work, you're now ready for a bathtub instead, or you're ready for an additional bathroom or half bath or something like that. Or you get older and you want grab bars, you want accessibility to the bathroom. You're able to change it over time, but you don't have a construction crew coming in to rip out what's there and throw away all this material. You have a way to recycle the entire bathroom pod. It goes back to the factory, it gets refurbished, it gets passed on to another user, or it gets disassembled and responsibly upcycled instead of just destroying everything and starting over each time. So I think in terms of life cycle, it makes more sense. In terms of consumers, it makes more sense because you're getting what you need when you need it. And in the middle example with a utility closet, some of it may be just software upgrades. You could think of these like computers in the late 80s and early 90s, where you would buy a unit and you'd keep it for 3-4 years sometimes, but you might upgrade your memory, you might upgrade your graphics card, you might want an external keyboard that's a little bit better quality, you might want a different monitor at a certain point, but the base unit stayed the same, and you got software upgrades and you got hardware component upgrades over time. I think the utility closet's a very good example of this, and you can think about it not only individually and what it does for an individual consumer, but what it does throughout an entire building with a group of consumers. So here, let's think about a smart electrical panel. It's in an apartment building and there's multiple units and all these smart panels, the data is being collected and patterns are being recognized. And so maybe we're seeing that there's sufficient daytime use of electricity in enough units to justify solar panels on the roof, but you don't have to pay that extra $10,000 for a battery to store it because you're able to use it as it's being captured and drastically reduce the cost of solar power. But you've got to understand the utilization rates to understand that investment actually makes sense. And you've got to have the conduit in place between the units and the roof so that the units that want that service can take advantage of it. So that's a way that you could physically upgrade or upgrade with software over time. A final example is around retrofitting existing buildings. So here we have this module that's plugged into a building, and it's got the kitchen, it's got the bathroom, it's got the utility closet, all built into one. So this is a way we can help both old buildings and new buildings perform differently. So let's move from the sharing economy to this past year in the pandemic, what I'm calling the socially distanced economy. These trends will drive more quickly trends that were already underway. Elderly people who might have been thinking about going to a retirement home might not think that's safe anymore and want an option. If you're, otherwise healthy, but you have something that you need to go to the doctor for as a minor health check, you might not want to do that right now because of health concerns by getting sick by going to the hospital. We're all experiencing telecommuting these days, and is that really a good experience? Is there a good camera and good lighting, good sound quality? What's that experience like? How might we make it better? And then finally, distance learning. A lot of the schools are closing and a lot of kids are doing their education online. But imagine that experience compared to interactive gaming or to what's happening in the entertainment industry. It's really not the same quality. Maybe we can do better. Let's think about those three things as products. So here's a healthcare module. It could be an accessory dwelling unit in the backyard of your home if you've got that zoning. It could also be, these modules could be assembled into what I would call a mini campus, a small grouping. So you've decided who you trust to be part of that community, and that community is created temporarily as needed by a group of people. This healthcare module might have wearable devices to monitor your health. It might have some physical devices that are built into the module as well. And it might have good ways for you to have nurses and doctors check in on you and be able to help you with your prescriptions and all sorts of things. Likewise, you can imagine there's a variety of different office modules that could be produced. Maybe industrial designers and engineers need some 3D printing capability. Maybe somebody that's in finance or law just needs some other kinds of abilities about scanning and copying documents as they come in. But these modules would be slightly different based on their uses, and likewise, you can upgrade them or change them over time. Finally, the learning module, this idea is sort of around homeschooling, where perhaps one of the parents can take care of math and reading, but then you need to get into science or engineering or something more technical, and you need sort of a guest person to help. What often happens in these homeschool communities is small groups that trust each other, that have the same sort of health and safety practices, are agreeing to be part of a pod that gets together and take advantage of this. But, is this a unit in a backyard that a couple of your neighbors you trust use that with you? Or is it something that's put together as a mini campus that's a slightly larger group? But we don't get into the thousands of people that you might find on a high school campus or college campus. Very different environment. So these are some of the examples we've seen in the past year that I think will change what happens going forward. Now, let's go back briefly to a couple of issues that I think we've thought about for a long time, starting with sustainable design and green buildings. We know that a large portion of electricity is going to buildings, and a large portion of greenhouse gases are coming from buildings. And yet, because we don't have manufacturing level efficiency, we have 30 to 35% waste in almost all building construction projects. It's hard to imagine it's that large, but in fact, it's at least that large, if not bigger. And when we did a survey about 7 years ago of about 150 US construction companies and subcontractors, the net result we got was 8 to 10% of the construction industry at that time really understood lean practices that were equivalent to lean manufacturing. If you'd like to read more about it, you can Google Smart Market Report, Lean Construction, and get this free PDF report on that topic. When we interviewed the experienced lean practitioners, we saw that 62% of them said that the construction industry was highly inefficient. On the other hand, the other 90% that were not really lean practitioners, we asked them, and 55% of them said, oh no, the construction industry is highly efficient. So it's sort of a risk to have people who don't know the potential of manufacturing efficiency making an estimate of the level of efficiency in construction. This is an old chart from, I think, SciFi at Stanford, goes back 50 years or more. I think Paul Teichholz was working on this in the 80s. And it's showing that most industries like information, technology, and manufacturing have gone up exponentially in productivity, whereas construction has actually fallen in productivity. Even agriculture outperforms construction. And again, from the Economist, they're saying back in 2000 that it's about 30% waste in most U.S. construction projects. So not a great track record. Let me pause here and see if Caesar has gotten any questions in the chat that we need to address.
Things are rolling well. Things are rolling along well, Patrick. No questions right now. But before you continue, I saved everybody the download bandwidth. I've posted to this site some handouts for you to download yourself from this site. You'll see the Lean Construction Smart Market Report that Patrick referred to, as well as 2 other handouts for your reading convenience. And back to you, Patrick.
Great. Thanks, Caesar. I'm going to pick up the pace now. I'm going to go through this next section really quickly because I hope that most of you are already familiar with this. So let's start with some of the problems that cause this waste that we just talked about. The first is that the architects and engineers in using BIM technologies are creating basically permit drawings. The priority of the BIM software is to produce good quality 2D documentation that's required for contracts and required for permits. Manufacturers or subcontractors who are fabricating components need shop drawings. That's different software. It's a different kind of expertise that's brought to bear there. And these two do not speak to each other very well today. And trying to use IFCs and those things, I think, is also problematic today. And finally, the builder needs sequence drawings. They need a way to create a 4D model to understand how pieces are going to go together. Those are, in the simplest level, we've got those three basic silos of different software. The outcome ought to be that there should be an integrated model and integrated documentation. If you had that, then you'd want to connect it to cost information and schedule information. And if all five of those things were integrated together properly, then you could create a production control system that could begin to resemble manufacturing. Back up a minute to make sure I'm clear on this point about how the different geometry is being used in different software applications by different types of professionals. An architect, like me, is responsible for clearances in a building. So we care about the cladding on a column. The structural engineer that I would hire to help me on a project cares about the size of the beam and the size of the column. The structural detailer, who usually comes after the construction contract's been awarded, is using a different product to design the steel reinforcement inside the concrete. And then the builder is concerned about, am I going to use wood formwork or reusable steel formwork? And, how much do I need and how am I going to allocate those resources? And finally, the facility manager cares about all of those things together when they have to think about renovating the building over time. These are potentially 5 different software packages with 5 different types of professionals, and they're not well integrated. And I don't think IFC and that sort of file exchange system will solve the problem. So let's talk about going from the design side of the problem to the delivery side of the problem and on-site congestion. So the problem starts with trade sequencing. You're going to have the structural frame finished before the plumbers can come in and put in slope pipe. And then after they come through, the HVAC team comes through and puts in the large ductwork, and the electricians come in. And the sequence goes like that. The stored materials on site, the labor coming through, creates a lot of job site congestion. However, if we were to do off-site prefabrication, it brings up a new set of challenges. How large are the modules? How do they get transported? And how well do they perform on site? What's the lifting capacity compared to the factory output capacity? How do you balance those things? The outcome should be that when you've got the right systems in place, you can focus on the long-term operations and maintenance services in a way that's relevant to the way that the modules were created. As I said with my elevator example at the beginning, the maintenance and service is the big long-term opportunity and has the best profit margin, but it's got to be correspondingly related to these modules as they're created. If we look at a typical construction site and compared it to a highly automated automotive factory, we can see immediately the potential for quality control at one place and the numbers of problems that be created at the other place. Let's just run a side-by-side here and see. Now, when you're doing the excavation, the pilings, the footings, the sheeting, shoring, all of that has to be done on the site. So all of these stored materials on the left cannot be placed until that excavator is finished and is out of the way. That's the job site congestion problem. And when you're working below grade, that's going to be there forever. You can't do everything modular offsite unless you're planning to build above grade with the systems. Now, on the right, you'll see, by contrast, an automated factory in Europe. And you can get a sense of the scale by that big white cylinder on the top there is equivalent of 3 truckloads of concrete. And you can see a uniformed worker in blue below there checking the rebar. That big high-speed carousel with concrete is feeding into this gantry with essentially a 3D printer for concrete. So the distribution of concrete is more precise. It's on a vibrating table. It's sized to go into a kiln and cure. This product is exposed rebar on top because they're probably planning to either thread the tubing for radiant floor heat on the job site and sometimes in the factory. Also, they're looking to create a lighter weight product, and they're looking to do a final pour on the job site to connect these areas together. So this is a way to not only get a more precision in a factory, but replace the necessary formwork in the field. When I talk to some contractors, they say, oh, yes, we have offsite manufacturing. But what I see is something like the image on the right. It's actually workers indoors. And while this is creating some additional productivity, I would say 8 to 10% increase in productivity, it's really not the same as an automated factory or a lean process. It's good that they don't have the usual safety equipment requirements, no hard hats or steel-toed boots. They don't have on warm winter jackets because they're indoors in a comfortable environment. There's good lighting. The tools are near at hand. People can work safely. They can work in multiple shifts. You get a lot of efficiency from that. So I'm not saying you would not do this. I'm just saying it's we could do better. I mean, even 100 years ago, the Ford Motor Company had moving assembly lines. And I don't see gantries, and I don't see the work moving to the workers. I see the workers in these groups filling up the whole floor space. That's not really a very lean process. And the product delivered is this volumetric module. So you're now shipping up and down the highways a lot of air, a lot of voids, instead of thinking, when do I really want a volumetric product and when do I want a panelized product? So clearly we can do better than just workers indoors. Here's an example of just the precast parts of the systems, and we'll look at some of the things that these automated factories can make. This machine is creating the spirals from rebar coils that are for columns on the right, and on the left, they're creating some beams with a different machine. And you can see in the black cages in the back, the rebar and the coils. So these rebar and coils, that's your first clue about precast. These come in coils up to a certain gauge, but as the rebar gets larger, it only comes as straight bar and not as a coil that can be fed into a machine. So I go into factories sometimes and I see, here's the machine using the coil and producing huge sheets of rebar very efficiently. And, nearby are a bunch of workers tying rebar by hand in straight bars because we haven't understood the design and used the right size of bar based on the factory's capability. I think you've got to understand every station in a factory. How big is the kiln? Do they have vibrating tables? Do they have 3D printing of concrete? What are their capabilities? And how do you leverage those properly? Let's walk through just a couple of those. So here's a rebar welding machine. They also have rebar tying machines. Well, there's a certain width limitation about what they can produce. Right after this machine is another machine that folds those sheets, and it can fold in certain directions, but not others. You need to understand that as well, but in terms of what kinds of curves you could create and what kinds of shapes you could create. You could make beams and columns from this potentially, but you need to understand how the machines work. Very briefly, you also will be deciding whether you're going to do the running of these tubing elements in the field or in the factory. I think these white ones are probably for electric service. The green ones probably radiant heat. The blue is probably domestic cold water, and the red's probably domestic hot water. But those are the sorts of tubing that you might integrate with the exposed rebar. I think doing it in the factory is probably better, and having junction boxes in the field. This is a field example. And on the right side, we have the larger MEP components that are skid built. So after you think about the structural frame and the MEP systems, then you have to think about the modules. How much is going to be panelized and how much is going to be volumetric. What I think you should be doing over time is really creating a digital content library that builds in these parameters efficiently. So maybe this double T, the width is based on the size of the sheet welder in the factory. Maybe the thickness is based on the lift capacity for the cranes. You might add some additional mobile cranes that have less lift capacity. So you want to do a partial pour and expose the rebar. You also might want to load more of the double T panels on the truck, and you need to reduce the weight because of the highway weight limits. You also might have the length of this slab based on the bed in the truck and whether you would need a truck that has an escort or not. If you can have the trucks delivering any time of day, that's obviously better. But if you make these slab elements too wide or too long, they require an escort, and it limits when they can be delivered. So let me pause again and see if Caesar has questions for us.
I think, well, there's a question here, but I think that the question person will probably be able to better visualize some answers that you'll deliver. So as an example,
Okay.
Patrick, the question really hinges on, practically where do investments start in doing this? Is it really process change, or is there some revolutionary thing instead of evolutionary thing that needs to be done? And how businesses could really apply themselves starting today to kind of do that evolutionary change. I think that's really what
Sure.
this question's about, but
Okay.
please continue.
Yeah. So I think that these changes are process changes more than technology changes. And I think you're limited in the process changes based on relationships in your supply chain. How well do you trust your partners in your supply chain to be able to effectively make process changes? Those process changes are going to be reflected in contracts. We need to move to more design build, in which the architects and engineers are under the umbrella of the contractors and therefore could have access to the delivery issues and the timing issues. Likewise, I think the subcontractors need to be brought on for pre-construction services to inform what should be in the shop drawing and what should be in the construction drawings. So these are the kinds of changes that happen. First, I think they're contract-based more than anything. But let me get into some examples. So this is a normal architectural delivery process where you have a program delivered by a client. You come up with a conceptual design and a schematic design, and you go to get zoning approvals or some early permitting approvals. And now you know that it's feasible to build the type of project you want on the site you want, and you know it's going to add value and you can move forward. The problem with this approach is it's assuming that it's linear and it's one directional, and you go straight from schematics to design development to construction drawings, and then you go back and forth a little bit perhaps and refine the design, and then you move into construction. I've never experienced a project that moved steadily forward and did not have to go back and rethink things. So this current process we have in our industry, I think, is problematic. By contrast, let's look at how industrial designers work. It's quite different. If you're thinking of products like a bathroom pod or an appliance or any grouping of components in a building as if it were a product, you start very differently if you're an industrial designer. Industrial designers are thinking about what is the kind of change, the kind of outcome they're interested in. They're like anthropologists. They're studying, behavior and figuring out how to make changes to that behavior. So the industrial designer works with a user interface designer, a user experience person. They do research. They see how things are being done now and how they might be done differently. And they go through a series of iterations and come up with some crazy ideas. And eventually they come up with 2 or 3 candidates they think that are pretty good. So they produce early physical prototypes, and then they put them out in the field and test them and find out which one gets the results that they're looking for. They choose a preferred prototype and they get into formative testing. Should it have a plastic enclosure, a metal enclosure? How do we waterproof this thing? So they start to think about how do we make it? And then they go to something even more important in the 4th stage, which is production design. How are we going to make it? Do we outsource it? Do we make it ourselves? And they put all that together and they have the first iteration of a product, but it's not imagined to be static. By contrast, this is state of art for modular design and construction. So on the lower right, we see this module going onto a truck to the job site. It would probably take 3 of these modules to make a 1-bedroom apartment, and probably 4 of these modules to make a 3-bedroom apartment. It's a volumetric module. It's, as you can see at number 1 and number 2, a self-supporting steel frame. It has an interior partitioning system added. It's got kitchen and bathroom pods that are integrated into it. Not a bad product. And then just above that, you can see there's another solution that is for the hallways and public spaces. So those 2 are credited as modules. when this kind of company that has this factory capability analyzes a building, they see a diagram, something like the one on the left. In green and blue are the things that they can do very well and efficiently, and orange, yellow, and red are the things they can do less well. So ideally, they'd be interested in splitting the contract, have the excavation and the podium for parking done by others, even have the stair and elevator core done by others. Then we'll come in and we'll put our blue modular solutions for offices or apartments in, and we'll put the green facade system that's a manufactured product in. But that's a very simple way we could break things down. This is completely different than what happens in automotive and other types of manufacturing. If we look at automotive, for example, and they talk about a modular product, they're not talking about volumes of space carved up to fit on the back of trucks. They're thinking about systems that go together. And they think in terms of three primary systems. They have these green fixed standard components that are the basis of the platform. That might be the chassis, it might be something to do with the drivetrain. But with that one fixed system, they can produce 5, 6 different products. They could make a family van, they could make a hatchback, they could make a sports car, they can make a coupe, they can make a bunch of products. This is very old. This stuff from Peugeot and Citroën goes back 20 years or more. What we're doing today with Volkswagen, with BMW, with Scania trucks and buses, these new modular systems are really quite sophisticated. In the case of Scania, for example, they previously produced about 130 different buses and trucks, and they had that many different systems. We were able to work with them and get them down to about 18 or 20 submodules from which they can produce about 350 different trucks and buses. Properly understanding the modules and how they come together to create different products is really essential. The second area that we have here is in red. It's the scalable elements. That might be the body of the vehicle or the interior compartment of the vehicle. And finally, we have the customized components that are the most expensive, like a sunroof or special bumper packages, those kinds of things. But those are paid for as extras by the consumer, and they don't really create a problem in the manufacturing process. The goal is that 80% of a product on a platform should be developed from fixed and scalable elements. Now, when I talk about automotive or even air and space, a lot of times people push back and said, oh, but every one of our buildings is unique. And, it's a much more complicated thing. Cars, they're making tens of thousands of cars. They have so much repetition that they can take advantage of modular. Well, guess what? This is our customer, Meyer Werft, that does these cruise ships for Carnival and other folks. They produce this product in 18 months. So from the time you sign the contract, 18 months later, in the port of your choice, this ship shows up with a trained crew, all the linens, all the food, all the consumables are on board, and they're ready to take on passengers. That is a lot of precision and timing and control of quality and result. And this is a 5-star floating hotel with movie theaters and sports venues and all kinds of things. So this is as complicated as any building, and there's no two that are exactly the same, yet they control the quality. And they get a very good return for this kind of process control. So let's go from the ideas that are, how industrial design is different than architectural design to some better understanding of production engineering. So this diagram, I think, is one of the simpler ones I can show to explain this. Today, BIM is really off to the left from this. It's out there at 0. What we need at number 1 is a solid model or a fabrication level model. It's got to be put onto a data platform. We will call that a product lifecycle management, PLM platform. And the kinds of things you do is create a construction bill of materials and a work breakdown structure. So you can begin to look at logical routing and systems, and you can begin to do planning for logistics. You can plan what you'll do in a factory, what you'll do on the job site, and what you might do near the job site. Most importantly, you come up with an execution system that builds in worker safety. Another way of looking at this is something like this project in London that I've been working on. where you take a Revit model or some other BIM model at the beginning, you bring that onto the platform, you integrate it with the fabrication models, you begin to break out the sequencing, when each of the parts is necessary to be on site, how the assembly is done on site. You start to think about equipment design, the use of workers. You think about the materials, and then you begin to simulate all that. And then after you've done the initial simulations, you optimize it. Very different process than what we do today. Finally, let's talk about on-site control. And I'm going to go through this fairly quickly. I'm going to just give 2 slides to summarize it very quickly, and then I'll get into some more detail. I think there's always going to be a need for a full-scale mock-up. It gives a quality control sample on the job site, and the workers know exactly what it is they're supposed to do and what the expected outcome is. But I think you've also got to have a virtual mock-up, a parametric model that binds together exactly how a change in one place ripples through the rest of the project. These two have to go hand in hand, and they need to be coordinated by laser scanning on the job site. These diagonal lines and horizontal lines that are dotted you're seeing, those are cables, either safety lines or diagonal bracing that are temporary until the facade's installed. And as the elements are installed, if it turns out there's an accumulated error, you can report back to the factory and have the future components shipped that have been adjusted to address that accumulated error in the field. So this is the sort of thing we see frequently, is this communication between the factory and the field being improved. And most construction companies that have in-house manufacturing or close manufacturing partners, this is a critical element. So if we think about the components here again, we're looking for a logistics control system, my lifting capabilities of mobile cranes and tower cranes, my transport capability with trucks or other train or however you're going to deliver, and the necessary buffer zones that I have to create. That logistics system is one way of understanding limitations in delivery. As we said earlier, you've got to understand system sequence, going from structure to plumbing to HVAC to electrical. You've got to understand the systems and the trades. And then you have to understand supporting material sequences. When do you need props and supports and scaffold? When do you need temporary facility? And when do you need to have it removed? Most importantly, what are the workers doing and how do we manage worker safety? So this is all of these elements coming together. And we can think of the factory simulations in a little bit different way here. The simulations show current product being made in a factory and how those products are being shipped out to the job site. So here we're doing off-site simulations for production. And on the right side, we're doing the field simulations, what you might do in a 4D software today. What that 4D software leaves out is manufacturing integration and worker safety down to individual worker ergonomics. So in this case, as we do the simulation in the factory, we find something that's changed in the field and we have to adjust. We redo the simulation, and there's a simple script that tells the robots to change the work. And it gives instructions to the individual workers about what has to change. This is a matter of coordinating field and factory in minutes. Obviously, there's a control process and a release process that makes it longer, but it doesn't have to be weeks. It can be hours in which a change is coordinated between factory and field. And in between that, you need a collaborative platform so everybody's aware of what's happening and how problems are being addressed. So I think I'm just about on time. I'm maybe 2 minutes late, but I've got time for a bit of Q&A. If Cesar, you want to pass some questions to me?
Sure. Let's take one question that showed up in the chat. You'd be able to see this as well, Patrick, so that you can read it, and I can dictate it as well. Yeah. They like the presentation for sure. As labor cost varies in most countries, many countries with a low labor cost are preferring traditional construction, even though they might know about modular building. What should be done to use more feasible lean construction by using modular product design processes?
Yeah, I think the labor cost has to do more with the level of automation, I think you've got to look at 3 separate offsite scenarios. One is using an automated factory, which has very quick output and very high quality control, and you then have to productize the building to leverage that. But I think it's also makes sense to have a near site assembly location for very large components. So, within a block of a construction site, to have a warehouse or some space where you can do near site assembly of these systems. And in that location, you'd have much more labor and much less automation. But if you're just getting started, and you're setting up this factory, you might do the workers indoors things that I showed. You will get about 8 to 10% more efficiency just doing that. So off-site manufacture in spaces that have gantries and the right equipment, coordinated with logistics to near-site assembly, and then finally, what are you doing on-site? The goal is to have the minimum number of parts delivered to the site and have the minimum number of connections between those parts. But you've got to look at near-site, off-site, and on-site together to get to that. Does that answer the question, Susan?
I think it does. So we'll just hold off on just a few more questions. Just wanted to wrap things up for you. Mm-hmm. Excuse me. Patrick, before you set yourself to mute, can you just confirm you can see my screen?
Let me make sure I've stopped sharing and that I can see your screen. It's loading.
Yeah.
I can see it now. Go ahead.
Thanks, guys. So overall, thanks, Patrick, for this. My name is Cesar Ruest, and with this, I'm really welcoming you to DfMA. All the players that you see there, from contractors all the way down to planners, this really is a holistic type of approach for building, and you don't have to boil the ocean at the end of the day. So I'd like to represent Dassault, just like Patrick, but really bring it back home to why Dassault for this. Since joining Dassault earlier this year, I've found we have the best AEC collections that is really, it is the best kept secret from the AEC marketplace. The piece that's really differentiating between Dassault and others is our 3D experience platform. It is a common data environment. It allows the users, like Patrick said, from an industrial design process where you have multiple iterations, it allows for concurrent iteration, design review, simulation, engineering, and anything dealing with systems of parts, a system of design. That's why the platform is a huge game changer for AEC. Consider yourself inside of this orange box. You are part of a company. You have maybe inside of your company different business lines. You may be working with subcontractors, other designers, and of course clients. When you engage in a 3D experience platform, this compass is not just a symbol. It is a single-click access through a browser that allows you secure and indexed data. So live working through a cloud platform is what we're offering. If you go to 3ds.com in the future, we look a little bit different than your standard software manufacturer. If you're looking for AEC and plant industry solutions from Dassault, you can find us under energy and materials for plant solutions, or energy and mining and offshore drilling. Or if you're part of the AEC industry, more whole for buildings, infrastructure, roads, bridges, tunnels, you'll find us under construction, cities, and territories. And as Patrick was showing some ways that the process can change without having to boil the ocean, process can change at the root of design, and then following that in conversations and contracts with the other stakeholders. So consider your role as you have it today. Everybody's doing their work effectively, but to incent you and reduce the amount of rework, this is where we see it as a transformation of BIM to a digital twin experience. What you see in the video playing just above here is the 3D Experience platform, allowing users who are designers, fabricators, people that are monitoring the project, people that are servicing the project, their own dashboard view of going through model, geometry, project planning, scheduling, and so on. So every dashboard view is a view into the platform and essential to any common data environment. If you thought about Google and if you thought about doing a Google search, you would enter into the search browser what you're looking for, and it would search on the data. And that's what our platform is really differentiated on. Use this search engine up here to access the data environment, and you can actually take advantage of knowledge reuse. You know, what did we do 2 years ago on the project, which was the condominium project downtown Toronto with some glass railing? How did we reuse that, or how can we reuse that? This searching mechanism allows you to search the entire common data environment. And here's the compass, which allows your users to jump into those roles, and one view of the dashboard for the team. Other parts of the team, you might want to do 1D all the way up to 5D, 6D, but this user would like to see their view, including models, diagrams, and all of that data that's interconnected with each aspect of the project or the model geometry. So it's a single click view to let that information be shared. Looking at KPIs and project performance, when model geometry is tied in a platform back to a schedule or Gantt chart, or trying to monitor the performance or risk index of cross project, this is where executives can leverage the data, which is going to be drilled out from the project. Highly intuitive, very usable. You can get up and running through this cloud interface within a matter of hours. And the investment that I'm going to speak about here in a second would surely be compelling. Work packages is something that I talk with contractors quite a bit in developing work packages and then executing on those work packages as well. So in the end, I just want to say your business, your project delivery partners, I'm presenting to you as being responsible for the North American sales for AEC, an ecosystem project pricing, meaning that I would offer to you special project pricing on the technology, the software, and your stakeholders on that project with you. We could rationalize a very incentivized pricing to get you started on the platform and all of your partners. If you want the risk removed from it entirely, unique to Dassault is that we actually offer, through our partners or through ourselves at Dassault, a goal-based project engagement, which basically means you don't have to buy software. We will help set up the goals with you, and then we will deliver that as a service engagement to you to basically take the risk out, but deliver you a final outcome. That's the goal. So fast and whirlwind, let's get into some questions and answers, Tom. And here's my contact information for those of you that wish to reach out to me at any time based in Toronto. So Tom, can I bring you back onto the forum?
Guys, I really appreciate it. I'm a bit biased, so not speaking on behalf of Kanban, but I've used CATIA in my career, and I was always super happy with the product. Extremely robust platform, you know, one of the leading platforms for sure in parametric modeling, and obviously the product has evolved quite a bit since I was using it, say back in 2003 probably. But really impressive stuff, and I really appreciate the insights in the presentation. I got a number of different questions. We are kind of at the top of the hour, so I'll try to be brief, but maybe Patrick, I mean, from your perspective, if you're going to give advice to a general contractor who wanted to, you know, think about the future of their business and think about going through a bit of a transformation, moving from, you know, competing on providing services to managing construction versus competing on producing a product and manufacturing a product that has total certainty, like what are the first steps in developing that? Do you, and on a macro level, do you think that a general contractor should be making a huge capital investment in a factory and setting up their own manufacturing capability, or would you advise that they instead focus on developing a robust supply chain and pre-qualifying global vendors?
Yeah, so I think you can work through partners initially, but I think you've got to look at your market. Are you multifamily housing and hospitality might be similar, but healthcare and life sciences are quite different. What is your market? When you focus on your market, there's two questions. Is there a repeatable submodule? In housing and hospitality, that's pretty obvious. It might not be as much in healthcare, but yet patient rooms are fairly repeatable. Nurses' stations are fairly repeatable. So what's the repeatable element? And then finally, I think you've got to ask yourself, what is the commodity part of the building and what is the special branded part of the building? I would say that a fire stair defined by code or a handicapped accessible bathroom is a commodity item and ought to be manufactured as a product. Whereas some facade systems are unique to the building and they're really part of the brand. The experience of walking into a lobby might be special. You might want to do that as a custom design. But those are the questions you have to ask first, and then you have to see how strong your supply chain is to support that. I'm not sure I answered Danya's question well earlier about labor. What we're finding in Europe and lots of parts of the world is a real shortage of skilled labor. How do you continue to give quality projects with a shortage of skilled labor? The metrics that I'm seeing in Europe are something like 50 to 60% labor reduction by this process, 30% cost savings so you can reinvest in higher quality, a 20% time savings, and still a 10% profit margin, even in that environment. So I think it's very compelling what's happening in modular offsite right now.
So, I mean, you obviously have like deep global perspective, and from your perspective, from your experience, where in the world is the most advanced in this, and what are the fundamental differences between how in North America we're operating versus these areas that are more advanced?
Well, I think China is making really significant advancements. If I look at their high-speed rail systems and infrastructure systems, they themselves are doing more than all the rest of the world combined. What they're doing in buildings is pretty good, but needs progress. But the problem is things that happen in China can't be reproduced outside of China because they're able to just reinvent from scratch. They throw away all legal precedents. If they need right-of-way, they just take right-of-way. So it's a very different operating environment. But their factories are getting better, and they give us ideas. I focus on Northern Europe myself because I find if things can happen and changes happen in Northern Europe, it's very easy for them to go from there. So I work a lot in the UK, and then I end up working in Canada and Australia and US because of that sort of relationship historically that happens. So I'm just now seeing construction companies in the past 10 years in Europe invest in their own in-house manufacturing. They're trying to be, more self-performing than they might have been in the past 20 years.
Yeah, it's got to be super difficult to make those big capital investments. With general contractors, typically, they want to hold as much cash as possible for bonding and to expand their business and kind of reinvest in R&D related to providing services. So to take your free capital and invest it in a factory to develop a product, it's a big fundamental change in how they think and how they operate. So when I think about offsite initiatives, I'm right or wrong, I kind of break it down in three different ways. So you got kind of volumetric prefab, which is the idea of building, volume of a building, like a C-can shaped object that can fit on a roadway that can be stacked up on the job site. And the second way is sort of panelized construction, where you take your design, break it down into flat packed elements that can be assembled on the job site. And then the third way is more kit of parts, where you might have all sorts of different elements, different shapes, different sizes, potentially washing pods I'd put in this category. And then you're designing around using that repeatable kit of parts, which is out of an existing supply chain or potentially your own intellectual property. Do you see these things, these concepts competing, or are they more applicable for certain typologies of projects and they complement each other? Or what are your thoughts? Or is there going to be like a competition over time on what school thought's going to get more traction in the
there's not a winner there. You want to do all of those things in the right proportion, and you want to do each of them for different reasons. You want volumetric modular components for congested spaces in which all of the trades have to go. So utility closets and bathrooms are a perfect example. Katerra has a good system of this. So when they deliver a bathroom pod to the site, inside the bathtub is the towel bars and all the accessories, the instructions and all the kit you need. It's sort of like the way that IKEA does furniture. You get everything you need in one package. So that area of volumetric, I think, is quite strong. I think much of a building ought to be panelized in the approach. It's more efficient in shipping, and it lets you make adjustments in the field in case a volumetric module is not perfectly right. And then I think with MEP systems, you also see something different than either a panel or a volumetric module. I think you want to use all three, and you just have to find the right combination for your building type.
Mm-hmm. So, question for Caesar. Caesar, I'm assuming you're still there. I mean, you're reaching out to engineers, architects, general contractors all over North America. Looking at a typical building, you have like curtain wall systems that I would put into the sort of kitted parts category. Then you have, air handling units and mechanical systems that maybe can be built offsite, structural steel. And then I guess the trend now is towards like, door assemblies, plumbing assemblies, panelized walls, washroom pods. From your experience working across North America, what's gaining traction quickly? What customers are really advancing quickly on this? On what categories?
Thanks for the question, and I am here. I love the question. It's almost like I paid you $1 to do it, but I didn't. The most compelling features that you talked about are pleasantly and surprisingly appearing inside of architectural firms who are looking to provide more services than just architecture. Mm-hmm. They are looking to provide fabrication level detail. They are looking to work closer with some subcontractors, and they want to have, they want to provide value where they can. They know exactly what they want to do as far as the visual look and the effective use case of a curtain wall or space. So I find there's a higher level of detail being introduced at the design and engineering levels now that they can have access to a tool like CATIA that can really take high degrees of detail across building, the actual volumetric shape of buildings at that scale, and then being able to work intelligently now, not just schematically with fabricators. And that is the starting point that I'm starting to witness and help the architects and engineers go down that path towards what Patrick is targeting.
That's why I was talking about the full-scale mock-ups in the field. I think there's a lot of need in design firms to have, whether it's a full-scale mock-up of a unit. So when I worked in condominiums, we often had 3 or 4 unit types that were full-scale mock-ups so that they could pre-sell before they started construction, whether it's the facade of the building for performative testing. I think that is, as architects and engineers do full-scale mock-ups, they already get into fabrication level issues, and that's the way they can enter into this market.
Right on. I have a couple more questions. We've already blown our time limit here, so I'm just going to keep going because I want to ask my questions. But are you seeing any developers start to think about the circular economy? I mean, or even factories, like from an industrial standpoint? A lot of big installations up north in the oil and gas realm. I'm sure they think about these giant modules that they're assembling, and they're probably thinking long term, maybe we can move that whole assembly like a batching plant in concrete. They do this regularly, but in industrial sense, for a factory, for a car manufacturing factory, maybe you can build it around something that can be dismantled and moved to an appropriate place where the labor's cheaper or closer to the material supply. Do you think that developers need to start thinking about that for commercial real estate as well, like being able to build a strip mall off-site, bring it to site, assemble it, and then in 5-10 years pick up the building and move it somewhere else and turn that into residential properties or whatever the case is? Yeah,
that's what I meant about these bathroom pods or other modules. They have to be individual, removable, and upgradable. It's not a matter of transporting the entire project. It's a matter of taking all the subunits that the project's made from and transfer those effectively. Now, when you talk about developers, I think we have to be clear about 2 very different situations. There are speculative developers who tie up a piece of land and do some evaluation and get zoning approval for change. And they're interested in selling it out at the end as quickly as possible. But then you've got developers like Jones Lang LaSalle or Lend Lease or CB Richard Ellis, these kinds of companies. They're developing products that they plan to operate themselves. So they're much more interested in this process because they see the life cycle advantage at the end. They're not trying to build a cheap product and turn it over as fast as possible. They're trying to create a really high quality product they plan to manage for 30 years by themselves.
Yeah, right on. The other big trend in this is global supply chain and globalization. So, right now, when we go to build a building in downtown Toronto, we're pouring concrete. We're dealing with local suppliers for the most part because we're managing land activities where we have to manage labor on the job site. Mm-hmm. And as the industry becomes more productized, obviously it opens up opportunities to purchase curtain wall from China, which is happening, and or new things like washing pods or mechanical systems as modules from an international supply chain. So do you see this trend changing? Do you see general contractors developing supply chain expertise and potentially putting supply chain managers into global markets so they can manage that? Or how do you see that evolving?
I see it as a distributed future. So let's look at Asia as an example. In the 50s and 60s, many electronics products were coming from Japan, and that was cheap. China started the same way about 20 years ago. It was supposedly because labor in China was cheap, but the shipping costs were still substantial. What we found over time is China was no longer cheap labor. It was more automation in factories that were bringing down cost, but still the transportation costs were high. So that manufacturing capability moved to places like Mexico. Now you save the transportation cost. You're transporting a shorter distance, but it's a labor manufacturing combination that brings down the cost. I think we're going to see another evolution from centralized manufacturing to decentralized manufacturing, that you create certain components in smaller factories in a more distributed way, and especially for MEP systems where the life cycle support of services is necessary at the building, you'd like the local manufacturer to do the services over the life as well.
Right. So it's going to be sub-assemblies and assemblies and then installation responsibilities.
Yep.
So kind of last question for both of you, and you can answer it separately, but maybe I'll start with Caesar. If you're to envision the impact that all these trends and the new technology is having on our industry, what does the industry look like 10 years from now? How have we changed? How are things improved? How much of our work is actually being done offsite? What percentage of a building or percentage of all work?
Most building types, 80% would be done offsite. It should follow the trends we've already seen in high tech and electronics and what we see in auto manufacturing. There's certain stuff that has to be done on site, like excavation and final assembly.
Right.
I don't see any reason why we wouldn't have 80% done off-site and why we wouldn't have a different type of subcontractor and a different type of manufacturer in the future.
Right on. Caesar, what are your thoughts?
I am glad that you asked, because this actually borders into the other question that I was going to add a comment to. So here we go. I see the opportunities for, I would say, large contractors, both here in Canada and the US. The large contractors partnering with other large contractors in a spirit of co-opetition. So if you want to take cooperation and competition, I would see that some GCs really trying to embrace the idea of manufacturing and creating a set of skilled people to do certain manufacturing things, and nobody does it better than them. And they will be then a sub, brought in to master that in one job and another. So I see the spirit of co-opetition. I see that there's going to be innovation there. And it's just a matter of, moving forward with a higher amount of detail, as well as the factory side that is really important that Patrick said, because you can't just start designing in one silo and then, wait a week for an answer as you send it over to the manufacturing silo. It has to be simultaneous or virtually simultaneous.
Right on. Well, thanks a lot, guys. I really appreciate the time. It was an excellent presentation. I just want to thank our audience for sticking around. I know we went a little bit over our time limit here, but we appreciate it. And I want to thank all of our sponsors. And I would encourage everyone to go to our website and check out the website. All sorts of really great information in there, including more videos like this that you can learn from. And also, there's a whole section on there on events, and we have a number of events that are coming up in the next couple of months that you might want to check out. So with that, I just want to thank Patrick and Caesar, and everybody have a great day. Have a great weekend. Thank you.